So if this is your first time hearing this word, it's all right. I think we might have heard of ZO, we might have heard of Cat's Effect, but what is Kio? I think this is probably what everyone's asking. So honestly, Kio is a lot more than an effect system, which we may already realize. It's actually a bunch of standalone modules which form this really powerful toolkit. So one of my favorite modules is Kio Data. These are basically low allocation alternatives to option, to either. These things are really powerful, and I think when you enter the workshop or when you just see the code, you may not see the value immediately, but on a larger code base, it becomes quickly apparent that these provide a lot of value. So this is sort of the magic one. This is Kio Prelude. This is where effects are handled. This is where effects are defined. And it's very cool because the approach is to have a side effect-free module. And so if you wanted to use this as an alternative to other Prelude libraries like ZO Prelude, you can completely avoid side effects in your business logic just by taking the dependency on only Kio Prelude. There's also Kio Core, and this is necessary because we need I/O, we need async, we need concurrency. These are very powerful constructs, and Kio Core is what I use, but if you have a more pragmatic approach with purity, then Kio Prelude is definitely for you. So then there's the Kio Scheduler, and this is actually sort of the secret sauce for how Kio Core is so fast. It's a very aggressive, high performance and adaptive scheduler. I've noticed using it in my production application for about 2 months now in my personal time, and it's been very good, and it's used limited resources to do a lot. So if you're using a ZO app right now, you can actually just take a dependency on Kio Scheduler ZO. It'll replace your existing runtime and executors, and you'll be able to run your whole application with the Kio Scheduler. Okay, and of course, we have integrations with Kio ZO and Kio Cats, which enable you to trivially convert between effect systems. Okay, so this is the big question. What are algebraic effects? And unfortunately, before we dive into algebraic effects, we probably should talk about effects in general, because as programmers, we like to have our own definitions for things, and this becomes a problem when we talk together. So, effects are probably the most overloaded term in functional programming. Most people end up describing side effects, not functional effects. So effects are really just descriptions of what you want. And the important bit here is that they produce what you want when you run them. And I think one of the values here is that they give you programs as values, which if you've been programming for a while, you'll realize this enables you a high degree of flexibility in how you use your programs, but also the understanding of your programs. The important part for effects, or how they're implemented, is that they're backed by suspension. So deferring the computation until later is very important to enable powerful combinators like retry, delay, all these things that we've all used. And this is because there's a separation of the execution from the definition. So this also enables delayed implementation. For example, if you've used a test clock or a live clock, you know that we need to have these separate implementations. And if you're writing in an imperative style or even just Scala sort of imperatively, you realize it's very hard unless you're going to pass an implicit or you're going to pass a parameter with a clock everywhere. It's very difficult to just use a test clock. And so what a lot of us end up doing is we end up adding retries or flaky, at flaky on the annotation of the test, but this is really not a solution. This is sort of a band-aid. And so, yeah, Kio of course provides this, but so do many other effect systems. Okay, so now we have effects. Effects are essentially just suspension and description of what you want. What are algebraic effects? Essentially, they're just extensible and composable effects. So they provide you fine-grained control over effect handling, as well as trivial combinations of various abilities. And an important part is actually this, just like effects themselves are the separation of the definition of code and the execution, algebraic effects should enable separation of effect declaration and implementation. And this is sort of mind-blowing at first, but effect handling can be distinctly defined, and so even users can create their own effects and run them using the core features of the library. So handlers are simply defining how effects are interpreted. Okay, so why use algebraic effects? And I'm probably the worst person to ask about this because at work I use Zio. And I think algebraic effects offer a lot of promise and they offer a lot of value. And personally I am using them and I'm writing a lot of code with Kio. But I can't give you that answer. If you're using tagless final or if you're using Cat's Effect or Zio, I encourage you to give them a shot and try it. But I don't think there's an answer because algebraic effects are sort of this novel new thing that has not found a footing in terms of why use them. Okay, I can give you an answer though to why use Kio. And this is maybe more important. First of all, it introduces extremely flexible algebraic effects to Scala. I'm not aware of any other library that's introducing the ability to have user-defined effects in Scala. And this sounds very minor, but if the whole point of using algebraic effects is effects, many of them, different abilities, then you want to be able to define your own. So the other thing is Kio is designed for an immense level of simplicity as well as performance. One of the things that I see with beginners or new users of effect systems is you sort of get this memorization or die. And what I mean by that is we've all been writing code before and someone else on the team comments, well, why don't you just use this combinator on this effect using this? And you sort of, your mind explodes a bit because you're so frustrated with seeing constant combinators and different ways of doing the same thing. And Kio takes a different approach, which is simple pragmatic APIs with the goal of allowing users to easily be able to find what they need. And of course, Kio enables custom user effects. Okay, so Kio syntax. This is probably going to look a little bit confusing, but let's talk through it. So the most important thing here is actually this is a val. And so, of course, effects, because they're lazy, they can be defined as vals. And even if it includes side effects, this will not execute the effect. But you guys all probably know that. So next we have the string. This is the result type. And then we have this weird less than symbol, which is actually like what we call the pending type. And so what you have on the right is the pending set of effects. And so here we just have string pending IO. In Kio, effects are represented as an unordered set of effects. And so when you see the pending type, you might actually see it more representative of this here. So you have file, pending, IO, and resource. And so the beautiful thing is you can individually handle each one of these effects and transform an IO and resource to a IO. Okay, so we kind of understand Kio syntax, we kind of understand what the algebraic effects are. Let's talk about how we use them and what effects, some of the effects that Kio brings. So IO. The above expression is a little bit interesting because we all use IO in our code bases. But one of the things that's important here is that IO is not different from any other effect. It's actually just a tag. In the sense that IO is just a simple suspension. It provides no additional functionality, but it enables you to specifically label all of your side effects. In other effect systems, everything elevates to IO, and I don't think that's necessary in Kio. So let's see here. You can handle IO individually, but for the most part, you're probably going to build your application, put it all together, and not actually run it. Your main app will run it. But of course, you can use the unsafe run. So one of the interesting things here, which maybe I should gloss over for now, is that you can notice once I've done this run here, what is the type? It's this chunk of person with pending any. What is a pending any? Well, it turns out that there actually may be additional suspensions, and there may be additional effects, even if they're not necessarily represented here. And the reason for that is because the core library needs to introduce suspensions for things like locals, for things like stack safety. And so, yeah, we'll move on for now, but I think that's an important thing to notice. Okay, abort. So if you've ever written Zio-style code, you know it's extremely common to use the E type as your short circuit. And the beautiful thing in Kio is you can explicitly use that when you want. So instead of having this Zio, any, nothing of A, you end up with just leading the entire expression. So it becomes just user pending IO. In this case, it's actually simpler than that. We just have a user pending abort, and the abort has a specific type. The cool thing is you can actually add many aborts together, and they can introduce those all into the type, and they can be used using type unions. So this is Scala 3 only. But as you can see, when I write this code here, I'm able to trivially switch between effects, and it's visible in the resulting expression. Abort, when run, produces a result, and a result is very similar to an either, with the exception that it can also introduce panics, which are, of course, system level issues, but that's not really relevant here. Of course, we all want to have the Zio R type enabling the dependency injection for passing in context where necessary. And this is a very simple example, of course, but the beautiful thing is you can add many different environment types wherever you want, and you can actually handle them all individually, or you can handle them all together. And we'll talk about that more in the workshop. Okay, this is the beautiful part about Kio, and I think this is one of the reasons composition feels so fluid. And this is because effects are able to be widened. So not only can I widen a pure value to be an effectful value, but I can actually widen a value that has effects to have more effects. And this seems like, at first, you're like, why would I ever want to add more effects? But it turns out we've all suffered from this problem when branching. How many of you have used Zio.win or some other combinator in Zio where, or another effect system where you need to branch, or the dreaded if X do Y, and then in the else case we need to Zio.succeed of 42 or whatever. That is a real pain, and it becomes very, very, very bothersome very quickly. And so with Kio, you can actually just say, in the if case, you can do or the else case, you can do your effectful expression, and then you can just return a pure value in the other case. So yeah, this is super useful for allowing flexible and composable code. And the sort of secret is that plain values can be widened to Kio computations. And I will note that widened values are not suspended in the general case. There are instances where they will be suspended, and this is generally not a problem, because if you're using pure functional programming, your expressions should not be unsafe or mutating, which is why in general you need suspension. And widened values do not allocate. So there is not only are widened values not saying, like when I write this, there's no implicit lift to a Zio.succeed. You're not introducing a box here. You're actually just widening the type. And so the beautiful part about that is that you can have very complex expressions which sometimes use effectful values and completely avoid the allocations for that. The other thing about Kio is that you get this beautiful unnested encoding. So if you notice, this function I wrote here, so this is a write object with an apply method, and it accepts this Kio computation returning a string with any number of effects, and we're going to get the value using map, and we're going to write it to some buffer. And apparently that buffer uses I/O, so that's interesting, I guess. And when we look at the code down here, you might notice that value is actually just passing a pure value. And if you look at the effect version, you might notice that console.readLine can actually abort. And so now we've introduced multiple effects here, and this is all apparent in the type. But not only that, but if you look at the original apply expression, we're just using map. And this is sort of the secret beauty of Kio, because with a map-only expression, you actually don't need this sort of flat map. And so all effects are included when you do a map. All the effects get joined into the right-hand side of the expression. And so you sort of avoid this constant question of, should I use map? Okay, now I need to introduce effects. Okay, now I need to turn that to a flat map. Oh, now that I have a flat map, I need to do zero succeed. This has really created like a beautiful way to write code. And this actually completely removes this whole category of code and simplifies how your expressions are written. So this is obviously a simplified example, but flat map is map. So yeah, the other important point here is the resulting type includes all pending effects. And so this is important because if you pass in some expression that contains pending effects, it's not going to just discard those or lose those. Instead, it's actually going to just combine those all into the right-hand side of the expression. Okay, let's talk about effect handling. So let's start from the top. A is just a pure value. It's being widened to a computation of int pending abort of exception. All right? And you'll notice that on the second line, B, I'm invoking this abort.run. And abort is able to handle one or multiple aborts. In this case, I decided to handle them all at once. And since there's no type union or multiple aborts pending, we end up with just a simple result of exception or int. You'll notice it's still pending any, and as we talked about earlier, there may be additional suspensions. Obviously here, there's not going to be any remaining suspensions because we're passing around a pure value. You'll notice the b.eval, and this is how you take care of those pending suspensions. This is pretty rare in actually user-defined code. It's more important if you're defining a library or if you're designing something internal to your application which needs to use unsafe logic. So this is something that's not visible in the slide, but important to note. Ordering of handling can actually affect the result type as well as the potential value. And so you can envision the case where I may have multiple aborts with multiple type unions, and if I handle one abort at a time, the resulting type may actually be different. You know, it might be a result of error 1 or result of error 2. And so you end up with this sort of complex type, but that's not really going to manifest itself unless you are doing some very explicit effect handling. And in general, I've found in writing my own code that the effect handling order is almost completely irrelevant. And instead, you'll just use effect handling where you want to manually or explicitly change the type. So one cool thing about Kio is there is direct syntax. I'm not a fan of direct syntax simply because I like fast compile times, but actually the syntax is quite nice. It's very beginner friendly, so if you're introducing this to someone at work or a friend who doesn't know anything about Scala, this really creates a way, if you've written Rust or if you've written JavaScript, from my experience, this feels very similar. And the cool thing is this is just, of course, transforming to map under the hood. So the Kio app, running your application. I found this a little bit funny because this morning I was trying to think of an example of what I should provide on screen that would be concise enough that you could see this. And I realized that I can actually just show you how to build a server in Kio. And so I'll walk you through that. Kio provides, of course, system utilities, and in this case, I'm just asking for a port. You notice I'm using the defer syntax, and of course, this is direct style. You don't have to use this. You could also use a for comprehension or just map. The beautiful thing here is, in just a few lines of code, we're able to build a server, run it, and you'll notice there's actually no explicit effect handling. And one of the things where I didn't include any type descriptions, but routes, when I call routes.add, this is actually not a mutating operation. Instead, this is using a sort of state monad or whatever you call it. And in this case, it's actually just an effect called emit. And so when I run this server, I'm not only am I explicitly handling this routes effect, but I'm also starting the server, and you'll notice it doesn't feel complex. I think a lot of people view algebraic effects as this magical thing that should be very hard, and they don't understand it, but really it's quite simple, and for the most part, you'll find Kio to be quite simple and easy to use. So, what is our conclusion? Kio provides a simple and powerful way to work with algebraic effects, and amazingly, that's available in Scala. It offers composability, type safety, and performance. I've really been impressed by Kio's performance in my personal projects. I've found it to be highly performant and very, very easy to use. It definitely enables a cleaner, more modular way to introduce functional programming, especially to those who maybe have no experience. And I've noticed this when teaching a friend on how to use Kio, and they had no idea what, of course, tagless final is. They don't know what f-bounded polymorphism is. They hardly even understand how Zio works. And in maybe 4 weeks, they were able to be quite productive in a Kio code base. And it's been very cool to watch them start to understand how Kio works. All right. Do we have any questions? In the back?
Yes, 1 minute.
I think next time I'll include an example of how to convert your f-bounded polymorphism or tagless final into Kio, but I didn't have time for that this time.
Hi, thank you very much for the very interesting presentation. There is something that I didn't really understand. You use, in the same way, the term user-defined effect and Algebraic effect, and I will know what is the difference between them, that are the same thing. And if it's the same thing, what are the algebraic nature of the algebraic effect of Kio?
So you said the difference between an effect and what?
No, user-defined effect and algebraic effect.
So a user-defined effect is actually, there's no difference between effects, and let's go back here. So effects in general are simply just abilities. And for example, the abort ability is implemented in what could be user code. However, it's included in the core library because it's extremely useful, extremely helpful. It'll be commonly used. And so the effect handling is pretty simple, and you can probably go look up the definition, and I think it's less than 100 lines, including all the combinators and all that. And so the reason I bring this up is because you can imagine a world where, take a step back 5 or 10 years in the Scala world, and everything was monad transformers. You were using monad transformers to change from one type to the other, and no one was bringing this sort of bifunctor approach of Zio or these other more advanced types that we have now. And if you wanted to introduce your own, I guess, change to the library, you would introduce a monad transformer, and you would have to call it everywhere, and you were constantly lifting and unlifting and running your code. And this was like very complex, and at work I have a code base that I really do not like touching because it's Scala Z and it's monad transformers and it's a pain, and this could have actually been completely prevented by just defining a single user effect, and it would be able to be just run individually or removed individually, and you wouldn't have this complex problem.
Excuse me, that was absolutely on my question. You use in the same context the term user-defined effect and algebraic effect. And my question was, is that the same thing? And if user-defined effect are algebraic effect, what is the algebraic nature of algebraic effect? So for example, in a language like Coca that introduces algebraic effect, there is 2 levels of effect definition. The first one is on the core library and are algebraic effect with equational reasoning approach. And the second one are user-defined effect that allow to just define resumable exception that are always reduced to algebraic effect. And there is, I guess, 8 different algebraic effects that are a very precise semantic textbook for in 2003. So what are the algebraic nature of algebraic effect of Kio if there is really an algebraic nature?
So it's actually, it's very hard to hear you down here, I'm sorry, but I'm not going to give you, I don't have a technical mathematical explanation for algebraic effects, but you can of course provide one or look into one. Coca, as you mentioned, is a very good implementation of algebraic effects, and I think they may provide the ability to do user-defined effects. When I say a user-defined effect, I'm not talking about a user-defined effect system. I'm just talking about like a single effect. Let's talk after.
Question from somebody who doesn't understand anything about effect systems, but you're using this ampersand operator between type names.
Yes.
And you keep calling that widening. But isn't intersection narrowing, not widening?
So I think this depends on if you're doing an input or an output channel, and it's a very hard thing to define. But in this case, the intersection of effects is reduced by removing effects. And so it's narrowing the type to be more precise, but I mean it's widening because it increases the scope of what needs to be handled. So in this case, even though the expression's pure, even though it's just a simple value, by adding these additional abort and resource, I've widened the set of what needs to be handled. And so yes, it's more precise type, and technically that's a type narrowing. I think it's a very difficult thing to explain unless you use the term widening, because that's really what it is it's increasing the scope of the effect. Is that helpful?
Yeah.
Hi, thanks for the presentation. Very interesting. There's something I don't understand. So, few slides before with the different example. So the UX-style approach, is it really learning the Scala compiler compiling the style normally, or is it some transformation that transforming into the use map?
So it's using the CPS awaits defer plugin. I think it's technically a compiler plugin, but I believe this could be done fully with macros. So this could be userland code. I haven't actually looked at the implementation of the direct style because it's something I don't use. But truthfully, there's a lot of ways that you could define your own user-defined defer await syntax, and I actually have there's a few ideas of how you could do it with simply functions, but you would not get this nice type descriptions here that you're able to use. So yes, it is just map and flat map, and the Scala compiler ends up seeing, at least once the transformations are complete, just map and flat map.
Thank you. If I have a Zayo application and I use the Zayo Studio function, does it mean that the effects from Zayo and the effects from the KO will use the same studio and then same script root?
Yeah, that's correct. So as long as your application, now this is a very common mistake I see. Somewhere deep in your Zoo application, you have somewhere that you say runtime.default.unsafe.fork or whatever you may have. And if you do that, you are now introducing the default runtime no matter what. But the way that Zio works, there's a fiber ref, which is simply a way to propagate locals across I/O suspensions. And of course, this fiber ref contains the executors you should execute on, the actual thread pools. And so the Kio scheduler Zio just taps into that and provides an alternative runtime for your application. And thanks for bringing that up, actually. It's very important to note that you're not, by using that scheduler only, not only is it compiled for both 2.13 as well as Scala 3, but also it's not converting your effects to Kio or something. No, it's actually just at the scheduler level. So it's simply accepting a runnable or whatever the equivalent is. So.
That's the question. Thank you very much.
Thank you.